The goal of this video is to define work in terms of forces and to understand when work done is positive, negative, or zero. Work is defined simply as the scalar product of force and displacement. If a force acts on a mass over some distance, work is done. More accurately, work is the continuous sum of the dot products between a force and the path it acts along. Writing work this way allows us to calculate work when the force is non-constant or the path is peculiar. The dimensions of work is the product of newtons and meters, which is called a joule, abbreviated with a capital J. Consider a person holding a dumbbell at rest. Acting on the dumbbell is the force of gravity and the force from the person, which are balancing each other out perfectly. To calculate the work done by the person to hold the dumbbell, multiply the force the person exerts by the displacement of the dumbbell. Because the dumbbell is being held at rest, the person is performing zero work. By the same argument, gravity is also doing zero work on the dumbbell. Note that this definition of work is different from what you may be used to. Holding a dumbbell like this will certainly wear you out and make you tired, but growing tired does not mean you are performing any work. If you carry the barbell horizontally across the gym, the work done by gravity is perpendicular to the displacement of the dumbbell. Gravity had nothing to do with the horizontal displacement, and so the work done by gravity is still equal to 0 joules. Similarly, the effort you exert to hold the dumbbell in the air still accomplishes 0 work. If instead you lift the dumbbell through some height h, then the displacement of the dumbbell is anti-parallel to the force of gravity. Therefore, gravity does negative work on the dumbbell, equal to the force of gravity, mg, times the displacement, h. The person, on the other hand, did positive work on the dumbbell to lift it. If you put the dumbbell back on the floor, then the force of gravity is parallel to the displacement, and so gravity does positive work on the dumbbell, while the person does negative work, because they still exerted an upward force on the dumbbell. If they lower the dumbbell at a constant velocity, the work they do will still be negative mgh. If the dumbbell is lifted some height and then returned to its starting position, the net work done is 0. If you go to the gym and lift weights repetitively, moving some mass back and forth, then by this definition you are accomplishing 0 work, even though it will certainly be good exercise. We can expand this idea to an object taking an arbitrarily complicated path. Taking snapshots of the object at a few points along the path, we can determine how much work was done by gravity, which everywhere along the path must be pointing straight down. Granted, there must have been some other force acting on the object to make it move in this manner, but we don't know what that force is and are only concerned with the work done by gravity. Since we've labeled the horizontal axis as x, we'll use s to denote displacement. Everywhere along the path of the object, the infinitesimal displacement ds points tangent to the path at that point. The work done by gravity is the dot product between the force of gravity and this displacement, taken at every point along the path. So saying the object starts at point A and ends at point B, we can write the work as the integral of f sub g dot ds from A to B. The dot product is just the magnitude of the two vectors times the cosine of the angle between them. The force of gravity is constant everywhere along this path, so we can pull it out of the integral. ds multiplied by the angle with a negative vertical axis will always return just the downward pointing y component of ds, so we can rewrite ds cosine theta as simply negative dy, the displacement in the y direction. Our limits of integration then change to y sub a and y sub b. This integral is as simple as they come. It evaluates to just the difference of y sub a and y sub b. If I call that difference h, then the work done by gravity is still negative mgh. Negative because the force of gravity points downwards, while my net displacement points upwards.